talking about reflection today. Now, reflection is a flip over a line called the line of reflection. Okay, it's fairly simple. Line of reflection is what we flip over. Now, each point and its image is the same distance from the line of reflection. And like we mentioned last time, a reflection is an example of rigid motion. Now, common lines of reflection are the x-axis and y-axis, or x equals some number, y equals some number, or the line y equals x. Occasionally we use y equals negative x, but we're not going to use that this year. Now, we can use y equals 3x plus 7, but again, we're not going to use that. We're going to focus on x and y axis, x or y equals some number, or y equals x. Okay, now if we take a look, these are already worked out, but I'm going to talk you through it. Okay, it says graph and label with the coordinates and reflect over what you're told. So this one gives you the coordinates. It says reflected over the x-axis. So the original is in red, and it says reflected over the x-axis. So the way this works is the x-axis is here, so you go 1, 2, then so it's got to be the same distance away from the x-axis, so 1, 2. You count how far down, so 1, 2, 3, 4, 5, 6, 7, so it's going to be 1, 2, 3, 4, 5, 6, 7. 1, so 1. Connect the dots and label the points. A prime, B prime, C prime. Okay. For the next one, it says reflected over the y. The y is the vertical line, vertical axis. So again, the original is in red. So you count how far to the y-axis. 1, so we go 1. 1, 2, so we go 1, 2. This one is 8, so we go 8. 7, so we go 7. Connect the dots and label the points. P prime, Q prime, R prime, S prime. And then for both of them, of course, it asks you to name the coordinates. So -4, -2 was A prime, B prime was 4, -7, C prime was 5, -1. Over here, same idea. -1 up 2, -2 up 5, etc. List the coordinates of the new points. Now, as a simple rule, when reflecting over the x-axis, the xy becomes x negative y, or opposite of y. Because if you noticed, A was at -4, +2, but it became -4, -2, so we just switched the sign. B was at 4, 7, and it became 4, -7. We switched the sign. 5, 1 became 5, -1. For reflecting over the y-axis, xy becomes -xy. We switch the sign on the y value. So if we look over here, 1, 2 became -1, 2. 2, 5 became -2, 5. 8, 3 became -8, 3. And 7, 0 became -7, 0. Okay. So it's just a matter of switching the sign on the correct value, correct coordinate. So here, okay, it says to do the same thing we did, but it says the y-axis. So for the y-axis, we switch the sign on the x. So -5, -2 becomes +5, -2. negative 2 becomes positive 2, negative 2. 0, negative 6, well, 0 is neither positive or negative, so it doesn't change and stays 0, negative 6. Negative 8, negative 6 becomes positive 8, negative 6. And so we graph those points. Now, if you're looking for another reason that 0 doesn't change, how far apart away from the y-axis is it? Well, it's on the y-axis, so it has to stay there. And then if we look at this one, it's over the x-axis, and we said that for the x-axis we change the y value. So negative 2, negative 4 becomes negative 2, positive 4. 1, negative 2 becomes 1, 2. 4, negative 4 becomes 4, 4. 1, negative 6 becomes 1, 6. Okay, I'm going to trust that you can graph this yourself for the new points and label them with the primes. Now here we have graphing over vertical and horizontal lines other than the axes. So for this one, it says to graph over x equals 4. So for these, there's no real trick to it. It's just graph the original and count. So sketch the line that you have to flip over, reflect over. And so then it's how far to get to it. So in this case, for k, it's 1, 2. So then 1, 2, put the point. 1, 2, 3, 1, 2, 3. 1, 1. Plot the points, label them, and make sure to put the primes. And then down here, it's what are the coordinates. So how far over, how far down, etc. Basic graphing that you should have learned back in algebra. Okay. And remember, because it's x equals, it's going to be a vertical line. Over here, same idea, x equals negative 1, so it's over here. We go in over 1 to get to it, so we go over 1. We went over 1, 2, so we go over 1, 2. 1, 2, 3, 4, 5, 6, so we go over 6. We go over 7, so we go over 7. And then again, label, write down the new coordinates. Down, for these ones, they're y equals lines, so they're horizontal. Same idea. The only difference is now, it's how far to the line. This time we're counting down. So 1, 2, 1, 2. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. And etc. Okay? It's basically, if you can count, you can do this. Okay, same idea with this one. Okay, count how far. Alright. Now, reflecting over the line y equals x. I can get into the nice complicated way of how to count and do this, but let's make it simple. To reflect over y equals x, we just switch the coordinates. xy becomes yx. So we switch the order. So negative 5, negative 2 becomes negative 2, negative 5. So it goes from there to there. Negative 3, 4 becomes 4, negative 3. Negative 1, 1 becomes 1, negative 1. We just switch the order of the points. Over here, same idea. I didn't sketch the y equals x line, but it's the same thing. We switch the order. 2, -1 becomes 1, -2. Sorry, -1, 2. 7, -1 becomes -1, 7. 7, -4 becomes -4, 7. And 2, -4 becomes -4, 2. And again, I trust that you can graph these points and label them. Now, we're going to skip these ones up here because that's the line y equals -x, so we're not going to bother with those. Now, here, it says to identify the line of reflection. Okay? Now, a hint says that it's sometimes helpful to find the midpoint of the point, of the corresponding points. Okay? So, personally, I like to look for the closest points. So, J and J prime. Alright? Now, first thing I'd like to look at is, are we reflecting horizontally or vertically? In this case, we're reflecting horizontally. So I look at the y-axis. Are these 2 points the same distance from the y-axis? 1, 2, 1, 2. They're the same distance from the y-axis, so it's reflected over the y-axis. Okay? And so that's it. 1, 2, 1, 2. It's over the y-axis. Now, for this one, again, I'm looking at it and I see that it's reflecting horizontally, but the y-axis goes in the middle of this shape, of this triangle. So it's not going to be over the y-axis. So that means it's going to be an x equals line, because x equals lines go vertically. So I'm going to look at the 2 closest points, R and R prime. So what's the midpoint of those? Well, right here is the midpoint. They're both 1 space away. So the question is, what's the equation of that line? And it's 1, 2, 3 on the negative side, so x equals -3. Now, if I take a look at this one, is it reflecting horizontally or vertically? Well, T and T prime, rather, they're reflecting vertically. So, it's either going to be a y equals or it's the x-axis. So let's check the x-axis. 1, 2, 1, 2. So they're both 2 spots away from the x-axis, so we're reflecting over the x-axis. Okay. And then we check this one. Again, we can tell that it's reflecting vertically. So this z prime is 1, 2 away from the x-axis. This is 1, 2, 3, 4 away, so it's not the x-axis. So we're looking for a midpoint. 1, 2, 3, 1, 2, 3. So they're both 3 spots away from this line, and that is at y equals 1. So y is 1 is our line of reflection. Now, for our last one, this didn't go C and C prime here, the closest. It didn't go straight up, it didn't go sideways, so it's not a normal one. So that tells us right away it probably has to be y equals x. If we check the coordinates, 1, 2, 3, 4, 1, 1, and 1, 2, 3, 4. So that's at 4, 1, and that's at 1, 4. They're reversed, so we know it's at y equals x. If you have any questions, let me know.